This was roughly the scope of my project at Woodcock and Wilson. Implement company standards, including naming schemes, parts used, and control of documentation. Comply with ATEX and IESEX standards, encompassing material types, clearances, and documentation. Reduce model generation time. Introduce laser, press brake, and standard operating procedures that work with Bystronic software and machinery. Create models that can be automated with CAM software. Set up and implement PDM Vault. Synchronize data with documentation, ERP, and drawings. Manage compliance and PDM workflow. This presentation is broken down into 7 parts. The driveworks modeler form, which can be used by an engineer to create a model, or by the driveworks configurator, which can feed the modeler form with data. The project structure, how the release macro works and what it does. The assembly structure, and why it needs to be structured. Model generation and sequencing. Creation of drawings, and why there needs to be post-generation tasks. So this is the main form for driveworks modeler. I am currently filling in this form manually, but this information also can be propagated by driveworks configurator. Our driveworks project consisted of 2 parts, driveworks configurator and driveworks modeler. Driveworks configurator is the customer-facing form that does all the quoting, stress analysis, duty calculations, and documentation. Driveworks modeler took that information and generated models from it. When the release button is pressed on the form, it activates the release macro, which sends all the specifications from the parent project to all the child projects. Information is then fed back and forth from these projects in sequence, so that information can be processed and calculated, and then the child projects are released. These specifications are released by the child for generation, and then the specifications are handled by driveworks Autopilot. Autopilot then takes this information and uses the SolidWorks API to generate SolidWorks files. When the child projects are released, then all the parts, assemblies, and drawings are created. Autopilot needs to know in what order to generate parts and models so that the correct parts can be inserted into the correct assemblies, and the correct assemblies can be created and then inserted into the correct drawings. First, all the parts are opened, and all the properties and references in them are updated, and the part files resaved and renamed and closed. Then, all the assemblies are opened, and all the part references and properties in them are updated, and the assembly files resaved and renamed and closed. Then, the drawings are opened, and all the assembly references and properties in them are updated, and the drawing files are resaved and renamed, then closed. After this stage, then post-generation tasks can be run on the child, and triggers can be used in order and sequence other tasks, such as pack and go, sending emails to customers, and moving dimensions on drawings. So here we have the fan case getting generated. All the parts and assemblies are being added to the fan case assembly, and all the references are being updated and the model rebuilt, which is why the sizes, shapes, and positioning are changing. So here we can see the drawings being created and the fan case assembly being added to the drawing, along with all the views and references. A post-generation task within the child will move the views into position, change scales, and positioning of the dimensions. Details can be added by driveworks or can be fed to PDM, which will in turn push the information onto the drawings. PDM can also push information from ERP onto the drawings, or from parts onto the ERP, such as product codes for purchasing. This is helpful because if a designer changes parts in an assembly, then the product code of that new part could be pushed to the ERP when the model is checked into PDM. So this is the final stages of the generation. Autopilot is waiting for triggers to be activated by the creation of files. This trigger is activated by a file being saved in a designated location. Once the trigger is activated, then files can be moved/zipped and emailed to the customer using a post-generation task. You can see here the email being triggered and sent to the designer to be finalized for approval. So now we can have a look at the final GA drawing and sectional view of the model. The GA will still need some finishing touches done by the engineer, but about 8 hours work has been saved here. This allows for a lot of scalability within the business, as turnaround time can be reduced, and the company's product can be sold and manufactured globally. The beauty of driveworks is that the design has been created using company standards, ensuring there is no confusion as to how the product should be designed, and that all ATEX IECX requirements are adhered to. This concludes my presentation for today. Thank you.